Good evening, everyone. Welcome to day one of your complete microservices training with industry use cases under the mentorship of none other than the senior principal IT consultant, a world record holder, TEDx speaker, a philanthropist, internationally recognized industry expert, Mr. Vimal Daga. Welcome each one of you all out here. There are different sets of learners who are a part of this training. Let me address to them individually so that you all feel that you are in the right training. Welcome all my Earth learners. This is a complete microservices training, which is a part of your program. At the same time, welcome to the DO 378 people who have enrolled themselves for Red Hat Global Training with the certification on Quarkus, which is microservices with Quarkus. Also, the ones who have enrolled just for my complete microservices training. And last but not the least, one of the most important training is starting today, which is system design, which is one of the most crucial training, also the most demanded one in the industry today. So all my different learners with respect to the different programs are a part of this program today. To give a brief overview about who your mentor is, I'm sure many of you all know him. But in a small, in few words, if I would like to describe him as a man who's working on a vision of awakening the youth through a culture of right education and working very, very closely towards making India future ready, building those creators from our nation who can be called as a technology creators, and people will follow them. He believes in that every student, every learner, every professional, specifically we Indians, can do wonders because we have the capability. It's just that someone needs to walk along with us. And he is the one who's going to walk along with us. He has remarkable achievements. One of them is being a philanthropist. He has served more than 3 lakh people in just last 2 years, absolutely free of cost, on various technologies like quantum computing, AWS, DevOps, and much more. He's the one who believes in the more you give is the more you get. And that's the reason he keeps sharing his knowledge of 20 plus years of the rich industry experience, the tested and proven industry skills, which all the companies across the globe, across the domains, have been using him for his capabilities. We are blessed that we have him, and he'll be sharing all the tips and tricks, the proven skills, what have been actually used in the production environment here with the real-time practical industry use cases. So thank you so much, Vimal sir, for being there for all our learners and actually serving the community, teaching these learners, these students, these professionals day in and out. Okay, without even thinking about, probably your health or prioritizing that. Thank you so much for who you are. The sessions will go over weekends, every Saturday and Sunday. Today is the day one. The next session will happen over the next weekend. It's just for the information. Everyone, just from the management perspective, everyone is a part of the respective WhatsApp group, wherein the session links would be shared with you respectively. Also, anything additional which needs to come to you will be coming on your portal, which as and when Vimal sir will announce the same. That's it from my side. Over to you, Vimal sir. Thank you so much.
Hey guys, welcome everyone. This is Vimal, and I would like to welcome you all to this very, very uniquely created program that is called microservices, right? We're very excited for this program because if you guys gone through the content or the agenda for this program, right? I would like to share you first before I go ahead. Okay, so way this content has been created for the microservices program. There's a complete all the possible things, whatever can possible in the microservices world is a part of this program. Okay, so in this training, we're going to start things from very zero. Okay, and we'll go to all the technical possibilities that can be possible in the microservices world. We will cover over here. All right, and I think this is the content everybody might have about the microservices program. I think as soon as Preeti has talked about, we have multiple set of students or the candidates over here in this training right now with me. Someone who is a part of just a microservices training, or I can say the advanced microservices training. We will guys complete this content in this program where we'll discuss about microservices, one of the very powerful topic called micro profile. There's different architecture of the microservices, service mesh, very powerful topic. And one of the interesting thing we are going to cover here is the Quarkus framework. Okay, even though there's multiple different framework available in the market, you guys might have heard about Spring Boot. Okay, so you can think Quarkus is a kind of competitor of Spring Boot. Nowadays, lots of projects, the corporates start focusing more on the Quarkus, and Quarkus has lots more benefit if you try to compare with a Spring Boot. As we progress in this program, I will keep on talking about. But this program give you a complete knowledge of the micro services. So in the future, whichever the framework you guys want to work on, maybe a Spring Boot or micro other framework, microservice related frameworks, or Quarkus. Okay, there's a much more framework available in the market you guys can work on. Okay, but the base framework we will use for the microservice in this training would be Quarkus. Okay, multiple different kind of projects we will build in this training, multiple different kind of transformation. I'll show you kind of migration, that if you have any kind of monolithic application, how and what kind of plan, strategy, tips, tricks, guidelines, standard practices you will follow to convert any monolithic applications to the microservices. We will discuss in this training, right? So multiple small projects, advanced projects we will build, multiple different architecture we are going to discuss about in this training, multiple type of design pattern we will almost, I can say, almost every kind of design pattern or architectural design pattern about microservices we will discuss, about the message queue, Kafka, synchronous, asynchronous call, different data management, distributed event management, or different kind of deployment, whatever possible we use in the real world, especially I can say the cloud native platform we will discuss, right? So if you go through the content, even though you guys may be new, that's what you are here in this training. So don't overwhelm with the terms. If you haven't heard about, don't worry, after this training completed, you will be well versed about every particular concepts, terms, and every different kind of use cases that can be solved with the microservices, right? So for this training perspective, there is no prerequisite for this training. This is the first thing I would like to start with. We'll start the things from very zero, and we'll move slowly to all the possible advanced things possible in the microservices. Okay, this is one thing for everyone. Second thing in this training is almost 90% and above 90% practical. Okay, today we'll talk about some concept part, so there will be no practical. We'd like to start today, but yeah, next class onward we will go more deep and start doing lots of things as a practical perspective. Okay, so for me, this training, because mostly the microservice training is more oriented toward concepts and plan and design, and more look like a PPT or kind of theoretical training mostly. Okay, but I'll create this training in such a way, and I plan this training in such a way that we will invest much time on the practical practical oriented and practice oriented. All right. So that I also believe if you guys have gone through some of my other trainings, if you're part of my other programs, that's what the approach I use, because I believe more you see the things going through practically, more conceptually understand what is going on in that particular part and that for that particular concepts also. Okay, that's one thing. Second thing is you guys might have gone through some of my trainings that you guys know about me, but those who by chance, if you guys we are this is the first time you are under some of my training, is so it is always good to know about the instructor. So my name is Vimal Daga, and it is always good to know about the instructor or your mentor maybe. So you can search my name in the Google and you will find tons of information about me, what we're doing, our motto, my different media coverage, press coverage, right? Different articles, blogs, or maybe LinkedIn, maybe one of the source. Okay, that is not completely up to date, right? In my LinkedIn, but you will get some idea what I do, which all tools and technology I have worked on. So it's been, I think, 20 plus year been in this industry, work with almost top possible company available in this world, right? And work with all the tools and the technologies, right? From machine learning to DevOps to cloud to microservices to n number of different tools, programming, full stack development, databases, right? Any possible tools and technology what is possible, I have worked in my career. And because in the microservice training, I've also did a lot of consultancy, I've been a part of multiple teams, help them to migrate from microservices to monolithic to microservices, and enable them in the containerized world, cloud native world, from IBM company to Deloitte to SAP lab and 100 more company, especially for the microservice perspective. So I have a huge knowledge base, what kind of difficulty you see, okay, well, while working with the microservices, what is the right platform to deploy the microservices, what is the best way to monitor or to orchestrate the microservices, okay, and what kind of challenges when you face while developing the microservice or planning when in software designing part of the microservices and ton more. So I'll trying to share you guys all the possible knowledge, whatever we need in the microservices and whatever I acquire myself by working on those top company and with the top projects. Okay, so there is some small information about me. Okay, next thing is for this training, it looked like if you guys are learning the microservices, so it looked like we should have strong development knowledge, or we should be developer. But I created this program in such a way, you are the developer, or if you might not be developer, does not matter. Anybody can learn this training, learn the microservices from this training. So you should not require guys to be software developer. Okay, so if you have any programming knowledge or if you have no programming knowledge, does not require any there's no prerequisite. I told you. So you guys from the DevOps background or cloud background or container background or Linux admins and something like this, you will understand almost everything about this training microservices. But if you have extra development knowledge, especially in the language called Java, that would always the extra benefit. Okay, because in lots of example, I will share you pre-created code, because this is not the programming classes, right? So I'll share you some app or some software or some code, and we will use those code. We'll do some changes that we don't require the coding skills there. There's some called annotations and something like this. We'll write some kind of keyword or some kind of attribute. Okay, it does not require any programming skills. And to convert our applications into microservices, and will utilize and then enable some facility on our application that is related to microservices. Okay, but if you have some knowledge of the programming, you can yourself can go more deep into it and they can try to do much more inside the code. Okay, but it does not mean you require any programming knowledge. Without the knowledge of programming also you can do it. But from our side, as a Linux world side, to support and to promote okay, that if you have some programming knowledge, especially Java, you can do much more thing in the microservices. So for this, guys, what we have planned as a Linux world, we will provide you guys extra training on Java. Okay, if you want to do, that will be your choice. Okay, but we will give you our Java training completely free. So we will I have my own Java training videos that we will provide to you. There will be no charge for you guys. It will be completely free. So whenever you get the time, just go through those videos so you can acquire some extra knowledge in Java. Somewhere, sometime it might help you, but it's not compulsory to have it. But I recommend it for my side, both the things. Okay, so that's what we will. So my team will share you soon that recorded class video for the Java. And before the next classes, try to touch some of the concept of as a programming language called Java. Okay, so this is one thing. So those who are there in the microservices training, this is the content we are going to cover. A lot of guys also a part of one very advanced training or the global training and the certifications program from the Red Hat. Okay, this is the program, guys, you have registered with us. It's called DO 378 or EX 378. So this is the special program for cloud native microservices, again with Quarkus. So this is what the content we're going to cover over there. One extra thing you will see in this content is we're going to deploy the microservices on the top of OpenShift platform. So again, this kind of integration and the deployment you will see with the OpenShift. Okay, and some more extra things you maybe look over and something like this will be part of this program. Okay, so those who are the part of a Red Hat training, okay, so this content will be covered for you. Okay, for you, even though some content might not be part of Red Hat, there's also covered over for you guys as extra bonus. But what extra content, what is there in the Red Hat program will be covered to you. After this program, you will be eligible or you will train enough to go for this the one of the advanced global examination by Red Hat. Okay, this is called EX 378 program. So this is the exam by the Red Hat. Okay, you guys can be eligible to go for this exam. Okay. By the way, for your knowledge, this exam, very limited guys in the world who have certified in this examination. I was the first one in the entire world, not in India, entire world, who passed this exam. So I was the first one, but by chance, till now, there's so advanced paper, there's so NIST, certification that very limited guys in the world is certified in this, and but this program has a huge demand in the market in terms of jobs and projects. So you will be the very limited world in upcoming days who is certified in this kind of advanced program. Okay, so this is one extra information. Those who are registered with Red Hat program, they will have this extra benefit. And one more last thing before I go ahead in this program, a lot of guys here also are part of one of our very uniquely created program. Okay, it's called system design. Okay, and in system design, there's lots of content related to system design, from solid principle to HLD, LLD, and 100 more content we have, from big data to full stack development to 100 more things. But one other topic that you have in the system design, who is a part of system design, is the microservices. Okay, not everything is about a microservice, a part of system design, but yeah, some of the portion of the microservice is a part of your system design. So whatever the content that is a part of the microservice in the system design, you will be there with us in this training, so that you guys also get the huge knowledge of the microservices by this program. Okay. So three category of participants we have. One for system design, from rather official training, and one from just microservices guys, right? So that's what I think you now understand why we have multiple category of participants here. Okay, but because the core part is common for all, so we'll cover the core part commonly. Then whatever the remaining portion, we will have a separate time and the slot for you guys. Okay, so let's start with this very uniquely created microservices train. Okay, and I believe, guys, this is the first time you heard this name microservices and you have no idea what microservices is. So today my plan is to give you a knowledge, or I can say introduction about the microservice, what exactly the meaning of microservices, why we need it, what kind of challenge we was facing. All right, and because of that challenge, why that will help us because of that challenge, right? What are those challenges that will lead us towards this idea or approach of microservices? But by the way, okay, nowadays without microservices concept, none of the top companies in the world can survive. If you go to any XYZ company, from Amazon to Netflix to Uber, XYZ company, right? Whichever the tools you're using or the internet, right? Their entire applications and software is completely built and planned using the idea called microservices. Without microservice, it would be nowadays impossible for these guys to survive in the terms of technical survival I'm talking about. Okay, so you might find hundreds of blogs about different things. For example, Amazon, Netflix, Uber, anything. Just this random blog I open for you. Okay, there they talk about if they don't have microservices, even though they was not using microservices, right? For example, if you look at Amazon, so in 2000 year, they was not using microservices. They were working purely on monolithic. Okay, and because of the monolithic, they're facing a lot of issues. So they have to migrate slowly toward the microservices, right? So similarly, guys, you can find 100 more examples. If you touch any company, like from Facebook to Uber to Ola to any XYZ bank, financial organization, right? Everybody have to work. Okay, and they use their applications that will build a plan or architect with the idea called microservices. So what exactly microservice is, let me explain you first. Okay, so guys, I'll go very slowly and step by step, guys, we will understand every term, almost every term related to microservices. Okay. I came to explain in such a way that you guys are very, very new. Okay, so that my base will be clear. Everyone base will be clear, so that when we start doing the practical, so if I use some terminology, you guys can very quickly understand, right? So my plan for today is to give you the entire basic concept of the microservices. Okay, to explain you the microservices, what I'm going to do, I'll open one of the website, okay, or one of the application I can say. So let's say MakeMyTrip. Okay, so MakeMyTrip is one company, one portal, or I can say one application in India. Okay, and we use this application like it is more like a booking.com. We use this application for booking the flight and hotels and something, especially for the flight and hotels. Okay, now if you talk about this application, even though guys, let me give very small terminology. Here is, okay, if you open any website and if this website is doing something for you, for example, open Google, if you open Google, so they help you to search If you open Gmail, they help you to send mail. If you go to Facebook, they're for social media. Okay, any website who will do something for you. So those are known as web application, or maybe we can use the word called application. And we can give one more name, it's called service. So they are providing some kind of service to you. Okay, so MakeMyTrip is one application or service. They're giving you one kind of service to you. They're helping us to booking the flight and hotel booking services they are giving to you. So now onward, guys, if I use the word application or the service, is more or small, almost the same thing. Okay, yeah. So if you go to MakeMyTrip, MMT, I'm using the word MakeMyTrip, and if you try to see the service, okay. So let's say some developer has created this service. Okay, some developer has created the service, and for creating the service, they have to develop the service, or they have to develop the application. And for the development, okay, they have some software engineer or the developer, right? They plan, they would like to use some language for development. Let's say they use Python, or let's say Scala, or let's say Java as a programming language. They choose one language for development of this service. Okay, and now what they do, they might open one kind of text editor or IDE, okay, and where they start writing the code, okay, for the development. And now what they write in the code depend what kind of facility we would like to provide, or what kind of functionality we would like to provide. Okay, one functionality, okay, that we would like to provide in this portal or in this app or in the service is that from this app, anybody can search the flight. Anybody can select that I want to book the flight from Bengaluru to Jaipur on this date and click on the search button. Okay, so again, some of the management guys from this company, they feel that if anybody come to my application, let's say MakeMyTrip, okay, we would like to give the client or the user, the customer, one facility, okay, or one functionality that they can search the flight. Okay, so let me write here. So one functionality, let's use one word called function, is search flight. This is one of the functionality or the facility. I can use the same thing, function facility we'd have to provide. Okay, so this is what I'm writing here. Okay, so this is one facility they provide, and let me search for here. After you search, they also provide some more facility. Okay, what facility they will provide you? So they give you options to filter. Okay, filter which flight you would like to have. We can filter with non-stop, we can filter with arrival, or let's say, let's talk about something else. Here they give you a facility that they will give you price. The AirAsia will have this price and this date, and some other company has this price and this date. Okay, so after search, they give you a facility that they can fetch, because if you talk about this company, MakeMyTrip, they don't have their own flights, right? They are the travel company. Okay, they have a maybe tie-up with multiple different company, the flight companies or airfare company like Indigo or Air India or AirAsia, something like this. Okay, so this company is like an aggregator. Aggregator means they connected with multiple different flight companies, and they aggregate the result, means they collect the result and show you one single portal. In one single portal, they are showing you all the flight names with the details over here. What detail they fetch, and they will show you here. They're showing you the price. This price is not coming from MakeMyTrip. This price, if you see here 6,000 something, is coming from AirAsia as a company, and this is the current price what is AirAsia is offering right now. Maybe after some time this price may be changed. So MakeMyTrip will go and contact AirAsia and fetch the price, and MakeMyTrip will go to Indigo and fetch this price. All right, so one more functionality or facility they provide you, they will fetch the price from XYZ company. Okay, there's also one functionality they will provide. Okay, but let's say depend upon we are the customer, we feel, okay, guys, I'm just trying to guys collect a lot of information because this is what we normally see. Okay, and guys, just wait for 5-10 minutes. I'll explain you by this example, why microservices and what is microservices. Okay, rather than going for the typical Wikipedia definition, I don't want to explain this way. I'm creating the storyline here. After understanding the storyline, then understanding the microservices and the challenge what we are facing will be very, very simple for you. Okay. So let's say they have some more facility. Okay. One facility would be, let's say I want to go for the flight called Indigo. Okay. So I'll go and select this particular flight, view price. They give the option called book now. So I click on the book now. So book now is also one more facility they provide. So after we feel this is the flight we're looking for, so they give the button here, book now. When I click on the book now, they will open a different page, maybe. Okay. But this is the one facility they're giving us. So one more functionality they give to us is we can book the flight. Let me use the word of book now. This is one facility or functionality they provide to us. And sometimes, guys, functionality is also known as module. So this is also one module they provide to us. So they have module for search flight, they have the module for fetch flight, they have the module for book now. And after we have the module for book now, okay, here they give you one more facility. While booking, if you think this price is good, otherwise by chance if you somehow we have the promo code, apply the promo code here, or maybe some promo code they show you here. Okay, right now the price is this one, 8,000 something, right? This, when I click on this promo offer, the price being discounted. It means this particular website also giving you one more functionality or one more module. This is called promo code. Promo code. Okay, promo code. So there's also one more functionality they provide. Plus they have some more functionality. For example, nowadays they start giving one more facility. They was not there in McMaTrip because I was the actual user of from McMaTrip. I never see this facility in some month back. They give options for book now, pay later. Okay, so you can book the flight right now by saying some small amount, and the remaining part you can pay in the later to just block the seat or block the current amount. So this one facility they added recently, last few months. So there's more functionality we have here. This is called book now. Let me use the word called pay later. Functionality they add or module they add. Okay, otherwise there's some more, like we have the exclusive member MMT Black. They have some extra benefit. Okay, they have some more facilities called travel insurance. Okay, or after I book, after I select, let's say that I want to book this flight. Okay, and I say continue. Let me give the name Vimal Daga. All right, if I continue, okay, I know I don't wish my trip to be secure, right? And continue. Here they say this is the details, confirm. I say confirm, and I can. There's one more functionality they give you. Long back was they didn't have, but now we can book the seat. Okay, this is also facility. So my point, guys, here is what I'm trying to explain you. Okay, so let me add one more thing here. Whatever I selected, okay, they have some functionality for booking the thing. So my point here is, okay, let's focus on this part, what I collected right now. Okay, so the guy or the company who created this website, let's say their name is McMaTrip. Okay, so they decide any customer come up in my website or the app or the services, we are going to provide these functionality or the facility or the modules. And the way they plan, okay, maybe the idea who has generated or the startup who has created, they say this is a facility we would like to plan. And then for this, to create this app, they hire the developer. They might be developer. Okay, and ask them, this is the facility we would like to create. And they start writing the code, something like this. Here they start writing the code, first statement, second statement, third statement, multiple statement or the instruction they write, and this functionality created. Then this functionality created. And then this functionality created. Okay, so multiple code they write in their programming language, does not matter, maybe Java or C++, whatever language they use. So multiple functionality has been created. Okay, till here everything is good, no issues. Okay, and finally, guys, you guys might know in one file, wherever you write the code or you write your functionality, it's called functions. This file is known as program file. Okay, so there they save this file with some name. Let's say this is a MakeMyTrip.service or MakeMyTrip.application or MakeMyTrip.java. So it becomes a program file. Okay, and you guys might also know whenever you have any program file. Okay, program file means where we write a code. And what code content? One code contain lots of functionalities, a lot of modules or functionalities or features. Okay, and what we do with the program file? Okay, this program file we always execute. Obviously, after compile, we'll execute or run. After we run the program file, a process start, or I can say my app start, or my services start. And only after service start, okay, somebody can use my service or connect my service. And mostly here, somebody from the internet, most of the client or the customer or the user, okay, they will connect the service or they will use the service. And what they can use the service, whatever functionality we provide, these are the functionality they can use, such as the flight, promo code. By chance here, there is no functionality for book the seat. Here, there's no functionality. By chance, I write here is to book the meal in the flight. But whatever functionality we have, that's what they can use. Okay, so who will use? The client will use these functionalities. Okay, from where? From my app or from my service. Till here, things working good. Okay, my app is started. My program has been started. Okay, but challenge here is, okay, if you notice here, if you talk about, let's say I'm going to have one more functionality. Okay, one more functionality we have. After we create the book something. So I have my own personal account here. And my account, I will manage all of my wallet, my trips. So all the flight I book or order booked will be mentioned here. So after a book, it will come in my trip. So my profile, let's say my trip is my personal account that make my trip is maintaining for me to manage my trips and my booking. So let's say my trip is one more functionality they provide us. Okay, it means whenever I book something, after booking done successfully, then they update the information here. I tell to this functionality that now new booking has done. Okay, so let's say I book for flight from Bengaluru to Jaipur is one city in India. Maybe some of the guys might not from India. So it's one city in India. Okay, so as I book this flight, after booking successfully, then they planned who the creator of or the developer of this program is exactly equals to a service. So when I say program is a way we write the code, but when the program run, it becomes a service or the app. So you can say one program is equal to one app. Yeah. And the developer of this program, right, after we book the flight, and if this booking is done successfully, some kind of conditions they write, okay, then update make my trip. Okay, update make my trip that, yeah, booking done for flight, this one from Bengaluru to Jaipur, there's a date and something like this, the update here. It means this functionality is depend on book now. A book now is also depend on fetch price. Okay, because if you don't know the current price, right? Because MakeMyTrip is not owning the flight AirAsia or Indigo and something like this, right? So while obviously when you book, you should know the current price, right? Or flight number maybe. Obviously it is free. Okay, so book now is depend on fetch price. My trip book depend on book now, and vice versa. Book now also depend on the promo code. Because while booking, you need to know the price, plus you also need to know the promo code also. Then only you can book. Means every functionality somehow depend upon each other. Okay, so this is the role of the developer. Okay, is the role of the developer. Again, guys, the way I'm explaining to you, we don't need any development knowledge. This is what we as a human being normally speak in this language. That's what the language I'm tapping here. Okay, but this is the dependencies we have. I can say one module is depend on other module, and other module depend on maybe 2 or 3 other modules also. Every dependent, but yeah, every modules together become my one single program or my one single service and my app. Till here, everything working good. My developer write the code, and after they write the code, application created, and my client can use the application. Okay, the challenge here is, okay, the way I create my code, okay, the way I create the code in one single file or in one single program or one single application, all the functionality I write in one single program. Okay, and you know one more thing. Okay, whenever you run a program run completely. It is not like this. If you run one single program file, if we have function number 1, we have function number 2, we have function number 3, and I can say we are running a program. Let's say program name is called flight dot some Java or C kind of program, and when you run the program, the only function 1 run. It's not like this. When you run the program, entire code run, entire function run, entire functionality start. Now it is the choice whoever use this application, the let's say client, which facility, which functionality or module or function or facility or service they want to use, or I mean, not a service, like say this functionality they want to use. That was up to them. But okay, whoever run this program, and running the program is sometimes also known as a deploy. So whoever deploy the program, okay, entire functionality will start. Okay, and this is one thing. So it means if you write a program where you write all the functionality together, so you have no choice. Okay, you have no choice that do you want to start this functionality or this functionality. Okay, you have to put and run all the functionality, all the functions together. Either my final customer want to, maybe my customer don't want to use pay later. They don't want to use. But because you write in their code in one single file or one single application, then maybe the customer is not going to want to use this, but this will have to run this functionality. Okay, so this way, this is not the complete and code, but this way of writing the code we used to run or used to write long back. Okay, but this way of writing the code, okay, or this way we design our code or architect our code, or I can say architecturing of the code in the world of software creation or the software development is known as that one single code means monolithic. So the way I am writing the code, a way I plan of writing this code in whatever language I understand is known as monolithic. Basically, one single application, one single big application, I can say, very huge one big application. It contain all the code. Maybe guys, if you are for a programmer, maybe one code means one project I'm talking about. One project means one project might contain multiple files. But when you start the project, all the file will start, all the functionality will start, all the module will start. But to make it simple, I write a code in this way, especially for those guys who are not the developer. The point here is when you create a project or when you create an application, okay, all the functionality in the application will start. Do you want to use or you don't want to use? They will start. That's what we need, right? Because we want everything to start. But challenge here is, okay, if you write a code or if you create your architecture for the software development as a monolithic architecture where all the functionality is there in one single app, lots of challenge you'll face. Okay, what challenge? Right now, if you are just new company, startup, very limited client, very limited facility, okay, So monolithic plan or architecture is not the big challenge. But if you grow, if your client will increase, more client you have, it's called customer base will increase. There are lots of difficulty you'll face, a lot of challenges you'll face, and solving those challenges is very, very impossible if you use monolithic approach. Okay, so let me explain you some of the challenges, and that will help us to plan a new architecture in the software development, and that will be microservices. Right now, we have one big monolithic app, or I can say one big monolithic service, one single mono means one single service that give you all the functionalities or the facility and modules. Okay, but this will give you a lot of issues. For example, I'm just giving you 2 or 3 different issues so you guys can relate, understand why we don't want monolithic. For example, let's say to run this functionality, fetch price. So when you run this program or module fetch price, okay, so let's say this fetch price will take the space from your RAM, from memory, because if you run the program, your program will run on the RAM. Okay, or maybe fetch price might need, let's say, 10 MB RAM, as I'm giving the random number here. Book now, let's say they need 100 MB RAM. Promo code, they need, let's say, 20 MB RAM. When I say RAM, I also mean to say CPU also here. So let's say they need 1% CPU, they need 10% CPU, they need 2% CPU. So I'm just giving in the terms of RAM, but typically I mean to say RAM and CPU both. This is called compute unit. RAM and CPU is the one who will run your program. This is called compute unit or compute program or compute device. Okay, so this is what they need. Now, point here is, okay, this is the minimum RAM we need, just for example, right? But what we notice, right? Because this is one single program, one single app, and to run one single app, one single program, we need one single OS, right? So we have one single system. When I say system, I mean to say the physical hardware. Physical hardware means your RAM, your CPU, your hard disk, your network interface card, and all the things. Plus your operating system, let's say your Linux and Windows or Mac, maybe mostly the Linux operating system. So this is the system you have. Okay, if you don't have the system, right, it is impossible to run the program or the services. So on the top of this system, we run our app or services, or it is also going to deploy our services or deploy our app. There's also a service. And out of my service is monolithic. So entire facility in the function from monolithic will deploy here and run here. Because they run here, so this program need 10 MB RAM, this need 100 MB RAM, 20 MB RAM. In total, this entire program service, let's say they consume 2 GB RAM, just for example. Or maybe in my base system, I might have only 4 GB RAM, for example. Okay, so if you have limited clients, okay, let's say in a day, only 100 clients come to a website, you are just a new startup, 100 clients come and hit your application. And out of this 100 client, the total 2 GB RAM is enough for your app. Till here is good, right? No issues. But as your application become more popular, become more viral, okay, customer will increase, maybe it's go to 1,000, 10,000 and some millions maybe, okay, and more customer come up, they hit your applications and the functionality more, and more CPU and RAM you need, or more network bandwidth you need. Okay, so maybe in the future, the fetch price might need more RAM, your search book now might need more RAM, your promo code maybe need more RAM, because more client come, more function they use, so more RAM, CPU, and network bandwidth or physical hardware you need. In this case, maybe you'll come to know, that if this much client come per day, so overall physical devices, we might need, let's say, 12 GB a day every time. So what can you do? Nothing very tedious. Whatever system you have, you will increase your physical resources. Initially 4 GB RAM. So the same system, we will go and increase, let's say, to make it 16 GB RAM or 24 GB RAM and 32 GB RAM. Increase it. Because you have more client you have, more resources you need. Resources means your physical hardware you need. Increase your resources. And you guys know what the one term here. If you have one single OS running, and in the one single OS, if you increase the resources, it's called hardware. Let's say 4 GB RAM, you have your change to 8 GB or 16 GB RAM. So in one single system, if you increase the hardware, it means you're increasing this called scaling. And this scaling is called vertical scaling. Vertical scaling. Only challenge in the vertical scaling is if you increase the hardware in one single computer, mostly you have to first shut down the computer. And after shut down the computer, then you add the RAM or CPU, then it can start. And obviously, if you shut down the computer, your application goes down. And obviously, your application goes down, client environment to connect. It's not good. You will lose the business, or plus you also lose the reputation that your service is down for some time. So client does not like this, and client might not come back to you in the future. Okay. So vertical scaling is good, but sometimes the challenge we have is when you do the vertical scaling, mostly we have to shut down our services or shut down the computers. But let's say we have a limited client. Till here, it looks good. Maybe some 1 or 2 minutes shut down, less downtime we have. So that may be okay. Okay. But here the challenge, what I'm trying to address you in a minute, is a very different challenge. So let's say till now, everything is working good and fine. Okay. But what we observe over here is this one single application running, one single service running is called monolithic service or monolithic application, right? What we observe, okay, that after every day, thousands of clients come up, or 100,000 clients gonna come up, okay? And what we see, okay, almost every client is only searching for the flight. Or maybe 90%, above 90% client is searching the flight. And let's say per searching, per client need 1 MB RAM, some percent CPU network bandwidth. This is a per client or per customer. Okay. So one customer come up, we need 1 MB RAM that point in time. Okay. So almost 90% customer is searching. While it's a 10,000 customer come up, so maybe all customer might require these many RAM, 10,000 MB RAM in total. But very limited guys go for fetch price, and finally very limited one will go for book now. Okay, so my point here is, okay, if you feel, if we have a lot of functionality or the module in our app or in a service, for one functionality or two functionality need more resources, more network bandwidth, RAM, CPU, and other things. Okay, but if they need more, we have to increase the overall system resources, and all system resources will give the overall scaling of the resources to entire app. But my entire app does not need the complete resources. Okay, my promo code very rarely we use. Pay later, maybe after 10,000, 2 guys use the pay later facility. Very limited guys, because they book the ticket. So very limited guys will go to my trip page to see how many trips we have booked. Okay, and something like that. But mostly they use search flight, and mostly they see the fetch price options. Okay, so point here is, okay, in one single big application, and right now I'm going to use the word service, or let's say the monolithic service. mono I'm using here, means one single big app. Okay. One app might have multiple, 1, 2, 3, only hundreds and thousands, depend upon app to app facilities or functionalities that are also known as modules. Module 1, Module 2, Module 3, and Module 4. In my case, is search, flight, and fetch price. Okay, but all this module and functionality in the monolithic world is one big application. One big application. An entire application is running and deployed on the top of one single system or one single, let's say, virtual machine or instance or the operating system. Okay, but challenge here is if one of the module or the function is being used more. Okay, so to increase the RAM and CPU for this functionality, we have no option to increase the resources for one function. For example, guys, if you ever work on any programming language, you write a programming file. Inside the file, you write a code. Inside the code, there's a lot of functions you write. Function 1, function 2, and module functions, right? And if you say, no, I want to give this function, okay, this function 2 GB RAM, function 3, I want to give 10 MB RAM, you can't do so. You can't allocate the resources per function. Okay, you can't resource it. You can't do this. So resources is being given to entire operating system, not to per functions or per module or per functionalities. Okay, but what we have seen here, okay, this functionality, let's say search flight functionality, is being used the most. And this is the one who need more resources. Okay, and because they use the most, okay, they use the most, because of this single guy, I have to increase my entire overall system physical hardware, that's called resources. Okay, so point is, in the monolithic world, okay, you can't control or you can't manage individual functionalities, resources. Okay, because of this function, I have to increase my overall system, or these guys might not require. Or there might be also possibility, maybe in my base system I have 4 GB RAM. You thought while planning, when you plan for app, you thought this functionality going to consume 2 GB RAM and this is going to consume only 10 MB RAM. 10 MB RAM. This is what the plan you have done initially. And you think now, according to this plan, my application will work fine. But there's a possibility some kind of clients come up and they start using this functionality more. This function, let's say book now or pay promo code. You thought promo code going to use only 200 MB RAM. Okay, but suddenly a lot of guys start using promo code. And suddenly their resources for this functionality increase. And because these are different functions running one single OS, they consume more resources. Okay, so what you plan for search flight, that much resource is not available because they are running on the same computer. So this functionality become slow down, because all these are functions part of one single app or one single program. One app function using more resource, so it will impact the performance of the next or other functionality and the module here, because every function is a part of one single program. One single part program is running in the one single OS. Okay, so point, guys, here is, in one app we have multi-facility. We never know how the client is going to behave. Okay, they might use one functionality more, so overall plan will be impacted, and because of one functionality issue, it will impact other functionalities. Okay, maybe somebody using book now or promo code again and again, because of this functionality, if they use more, this will impact. So in the future, somebody was searching the flight, it looked like this is slow. It's not slow. Promo code is using a lot resources that make the search flight slow. Okay, why? Because everything is a one single app running into one single computer. One function use more, other will be impacted. Okay, so my point here is the planning or the design, the way we architect our monolith application is not the right. Why? Because every modules or function running in one single system, so we can't plan our resources properly. This is one big challenge. Okay, so one performance hit on one single function, it will impact other module, even though they are different functionality, but they will impact the performance of other modules also. Okay, in more we can't do anything else because this is one single app, right? I can't do so that let's run the fetch function at the computer. It's one single app. Either this app will run completely or either this app does not run completely. Okay, in the monolithic is one single big app. Okay, all the functionality become one single app or service. Either they run completely or either they don't run completely. Okay, so we can't do so, for example, pick the search flight and run in other computers. Okay, maybe we can add one more computer. This, let's say this is computer A, this is the system B. So this entire app we can run here. This same app we can run here, but it will run completely. If they run completely, so again same thing will happen. Okay, one of the functionality use more, it will impact other functionality. Here, one of the functionality use more, it will impact the other functionality. And managing limiting this quota, setting the quota on functionalities is somehow very harder to manage. Okay, so right now what I'm talking about, the challenge in the monolithic is if your application has multi-functionality, any issue in terms of performance or utilizing the resources happen, it will impact the performance of other functionality. This is one big challenge. How to solve it, we'll discuss in a minute. Okay, second challenge here is, okay, this is guys about the challenge about the resources, means infrastructure challenge, means RAM, CPU, network bandwidth. So everything is like I can use the word called operational challenge or the performance challenge or infrastructure related challenges. Okay, there might be more challenges, but I'm just giving very brief. It's a first class, just trying to explain you in a way that you guys are very new. So by having this basic knowledge, you can get the idea that if you have the app, it's a monolithic, then having the performance challenge is very common. Okay, maybe search flight is working fine, but any other functionality will impact, right? This will be also impacted. Okay, second challenge is more about the development challenge. Okay, for example, okay, book now is a different function. My trip is a different function. Okay, so there's a possibility, because it's very common, guys, you're developing the code and having the bug in the code is very common, or adding the new feature in the code is very common. Maybe in the book now, button does not look good, I want to change the name. Or maybe I want to give more options. After you search the flight, you want to give filter. You can filter with the price and time and arrival and departure and all things. You want to give more options. Okay, so adding new code or fixing the bug, any bugs happen, is a very common activity. Almost every day, every time we keep on doing it. It's not things. It's not a common. It's not a rare thing. We always keep on doing it. Okay, so if you think some of the developer is updating any bug or fixing the bug or adding the new code in this function, okay, maybe this might be smaller change, in this functionality. But to update this change or provide this change to the customer, we have to redeploy the entire app. Okay, because this is one single app, this is one monolithic app. Promote code is working good, book now is working good, fetch price is working good. When the search flight, maybe small bug you have, one single line of bug, but to update this bug, what we have to do, wherever my app is running, in whichever the computer my app is running, it's called where we deploy it. This app we have to first shut down. Okay, and rerun it, re-execute it. It's called redeploy it. The challenge here is just for a small change in the search flight, we will redeploy entire code because it's a complete one single program, it's one single app. Or maybe that's point in time somebody's booking, the booking will fail. Okay, somebody is applying the promo code because application redeploy, that session will expire and might not work. Okay, so maybe some customer looking for because they always search the flight, they are doing the booking now page. Okay, because of something change in the search flight, the booking now code will shut down or might not work that point in time. So their book now process going on and transition going on will fail. Okay, so in the monolithic world, this is the one big challenge. Any part you will change because it's a very common thing we want to change because this might be a very important bug we have in search flight. But to update this part, every complete monolithic application has to redeploy. That will fail other functionality that is going on used by some of the customers. Okay, so point here is, idea is if you want to change in the search flight, so why to redeploy this? I don't want this, but we have no choice in the monolithic. We can't do so. We have to redeploy the complete app because one single program. We can't deploy only one function. Every function will have to redeploy, and every complete program or application to restart or redeploy. This again, one of the big challenge in the monolithic world. How to solve this challenge? We'll see in a minute. Obviously, you guys know the answer is a microservice we can solve. But this second challenge I'm talking about here. Okay, and and third challenge is, okay, one functionality can be dependent upon other functionality. For example, you want to do the book now it depends on the promo code. Okay, so there's a possibility, okay, if you do some change in the promo code, means the code, you do some change in the code, is code change in the promo code functionality, and whatever you change here, okay, it is not being updated in the book now because some change you write here, maybe you can change your promo code. Let's say initially I had a promo code 100% off or 1,000 off. Okay, this is the promo code you have. Let's say hard-coded promo code you add here. But in the book now, you're still using your older promo code, let's say 2,000 off. So it's a bug, right? We have code change, and here they still using the old one, or maybe hundreds of things can be there. Okay, so book now is a different functionality. This is a different functionality, but everybody is dependent on each other. If some part you change here, this part not work. If you don't update this module also, or if you don't update this module function also, if you don't tell this function that some part change here, accordingly you behave. So every different module, mostly in the monolithic, is somehow connected to each other. It's called tightly coupled. This might not be the perfect example. We can see more great example in the future classes, but I'm just trying to make it as much as simple this point. So book now functionality is dependent on the promo code. Something change the promo code might impact the book now. Where some promo code fail, or this functionality fail because of some error in this code, book now functionality might also fail. They're dependent. Okay, and that dependency is known as dependency, or there is sometimes also known as tightly coupled. So all the functionality and mostly all the functionality in the monolithic world is tightly coupled. Tightly coupled means they are dependent on each other. Means if you want to change something here, it might impact here. If this fail, this will fail. If you change here, if you don't accordingly change in this other functionality, so thing might not work the way it should work. So they are known as tightly coupled. So everybody is dependent. But maybe some customer want to use book now. They are not interested in promo code. They say, I'm ready to go for book now. I don't have promo code. I want to directly go and book the flight. We have urgent need. Why? Because of promo code, my book now is not working. Because you write the code, you have some issue come in the promo code that makes your book now functionality and mode also fail. But not everybody need promo code. But even though they fail, because they're tightly coupled. Okay. So this is also one of the tightly coupled is not good thing, but this is also one of the challenge in the monolithic world. Okay. So point here is, okay, this something like this, there's a lot more challenges you have in the traditional world, legacy world of creating the application. So in the older world or legacy way or older way, we mostly create an application, okay, in a monolithic fashion. Means one single big app, one single big service is providing you all the functionalities. Okay, even though if you talk about Amazon as a company, they was also initially created the entire app in monolithic. If you talk about Netflix, they also created the app in monolithic. If you look at the same example, what I was talking about, MakeMyTrip, initially also they create the entire application of MakeMyTrip in the monolithic only. And these companies face this issue, and there's some more issue we'll see in the future classes. They face these challenges. Okay, and because they face these challenges, so they thought, why not come with a new architecture, new software development architecture. Why we create a software? Why not we create a software development in a different way, different plan, and different approach or different architect? Okay, and the architect in such a way that this problem, some of the problems I was talking about, or this challenge can be very easily solved or resolved. Okay, and they come with a different approach of software development and the deployment both. A new approach they come here is they say monolithic has its challenges. Okay, so let's convert our software, okay, or transform our software in a very different approach. Okay, and that's called microservices. Now, what a microservice we'll see in a minute. Okay, but this is what they've done, right? So if you see this blog, or maybe one blog I opened from MakeMyTrip, and here initially is a online travel aggregator in India. That's what I told you. Most of the guys might know MakeMyTrip, but if you see here, okay, they shift from monolithic to the microservice architecture. Why? This is some of the issue I already talked about. Okay, or if you talk about this company, what I was talking about, Amazon in 2000 year was working on you might see in somewhere you can find the work in an idea called monolithic, and then they split the monolithics into smaller services. That's called microservices. Okay, what challenge they are facing? Again, some of the challenge I already explained to you, but we'll see more about and more deep into those challenges. So what the monolithic is? So microservices. Okay, so monolithic means we have one big application, one big service, giving you lots of functionalities. Okay, function means these modules, book now, promo code, something like this. Okay, and because it's monolithic means either you run the entire service or don't run the entire service. It work is one single box, one single program, or the app. But in microservice, what we'll do, okay, in this big app, split this app into smaller independent application or mini application or independent services. Okay, so what microservice is talking about? Okay, if they say search flight is one different idea, it is for searching. Why not we ask our developer to create a separate file, an entire code of search flight, remove from here and put here. One single program that is equal to one single app or one single software, or I can say it is also equal to one single service. So independent service create only for searching flight. Okay, so one independent small, okay, app. I can use the word called service also here. Every service, same thing. And this app is only for one single functionality or one single module, let's say for search flight. Similarly, we ask a developer to open a new program file and create one single functionality only for remove from here and only for the book now. So book now is a one independent, simple, small, dedicated app for book now. And likewise, other module and functionality. So what we have done, our big monolithic service now split or divided, okay, or transform into smaller app. Okay, and every app feel that the independent, isolated, they are the complete app. Okay, but every app is been further divided, and because every app is an independent services, that's why we use the word called microservices. They are the small microservices we create, and everyone work individually. Individually means if you just talk about this app, let's say this is app number A, is called search flight. So there's an independent app. So we will run this app dedicatedly on the different hardware or different OS and system. So they have their own personal RAM, own personal CPU, own personal operating system. So this app number A, search flight, is running in different system or different virtual machine or different instance. Okay. Or now the app number B is book now. They are running in the different system or different OS. Now it is your choice. This system is running in the virtual machine. They're running on the cloud. If you guys know about the container like Docker, Kubernetes, we know, or Swarm, you can run there. That will be your choice. Because the individual, this individual. Okay. So one benefit is, if you see here, if the individual, so what can you achieve here? It is something like this. Now we have one single service dedicatedly on search flight. So you can think search flight is a independent service, a whole complete service or whole complete application. They have their own personal physical OS and the hardware. Let's say, let me use the word ecosystem. Okay, so it means in the future, if any client or customer come and if they feel, okay, they want to do a search, and for searching, we'll connect this client to this app running in one OS, running on some particular IP address maybe. So just for searching, they only connect to this app. and this is dedicated only for searching. So again, it means if we go to again Make My Trip app, what was we have started here. Okay, so where you see this page for searching. Okay, so internally when you click on the search, actually we hit to this particular computer. Let's say this is a computer number A. Okay, so this search, what is happening right now, is being given us the result from this particular application, and this application is only meant for searching, or this service also meant for searching. So we can say microservice. Why microservices? Because it's not only service, multiple other services also, they work together and make the entire Make My Trip app or entire Make My Trip big app. But this is a small service they have. But what benefit you get out of this to split one functionality as an independent service? So one benefit you get in the future, let me add one more service here, by the way. Okay, if we have one more service, let's say Book Now. So Book Now is a one independent now app or independent service, even though it is very small service, so we can say it's a microservice. Okay, and they're running or they deploy in a different computer, different system. Let's say the computer number B will have a different IP address altogether. Okay, and in the future, any client, if they want to book the flight, okay, if you click on this button, okay, so internally, clicking this button internally, okay, will connect this client to this IP address or to different computer. It's not visible here, okay, because your front end will manage internal calls. We'll talk about it. They have different call or Ajax call. Okay, so there's a different point how they manage, but to make it simple. So technically, when I click do a Book Now, they will route me or connect me a different IP address, different services. Even though you can see in this way also how the route. If you see here, if you was searching initially in this page, so right now where you are in the /search page. Okay, so client is actually heading to this search flight in a path called search. Okay, this path is also known as route. You are in the route called search, means it is written somewhere in the Make My Trip. If anybody come to /search, okay, connect to this A computer, connect to this IP, connect to this service. Okay, but anybody who will connect on Book Now, okay, so you will see, guys, you are in a very different page, maybe review detail. So anybody come and click on the Book Now, then take me to different path. Let's say review detail, or this path could take me to a different route, different area, different location. Means different IP address or different microservices. How they connect, we'll talk about this point in upcoming discussion when we start setting the microservices. We'll talk more about route and other things also. Okay, they take me there. And now client will be dedicatedly connected to this OS. So what is the benefit of this? Okay, now search flight is a different functionality. Now it's become an independent service. Book Now is a different function. Now it become an independent facility or the module or the service or app. Now, what benefit you get out of it? Okay, the benefit is one challenge we are facing. Maybe in the future, okay, suddenly my application goes viral, hundreds of thousands can come up. Mostly everybody will search, not everybody book. Okay, so let's say suddenly 10,000 or 100,000 clients come up for searching, or maybe hundreds client only is there for booking. If 100 clients is there only for booking, then one single computer with limited resources, RAM and CPU is enough to serve them. But if 100,000 computers client is coming for searching, one single computer is not enough. So in this case, now we can independently scale this guy. Either increase the RAM or CPU in one single computer, Let's go vertical scaling, or what we can do one more thing. We can add exactly one more copy of this guy. Same OS we'll install, same system we will create, same search flight app or service. It's called microservice. We'll add one more copy of it. Okay. So we can add one more computer. Let's say this is a computer number A1, this is a computer number A2, might have different IP address, have the same copy. Okay. And if any app are running into more than one computer, 3 computer, 4 computers. Okay, why I want to run same app in multiple computers? Because we have a lot of clients is coming. So some client that is coming for search will send to this computer number A1. Some client will send to computer number A2. This is called load balancing. Okay, why we do load balancing? Because a lot of load is coming, multiple traffic is coming, so it will be balanced. But adding more computer is called scaling again, but this is called horizontal scaling. Okay, but now guys, we are doing horizontal scaling, not the entire app. Technically, the entire app is MechMyTrip. So we are not increasing the entire MechMyTrip. Because MechMyTrip have a lot of functionality, promo code, connected with banking, my personal account, my trip, okay, review details, search page. So we are not increasing, doing the horizontal scaling for every part of it. Whichever part we feel we have more load, that particular microservice, we are scaling. We add in more computer, we put in more virtual machine, or maybe container, wherever you deploy it. And why is possible? Because now search flight is functionality, but that function now has become one independent service. Small service is called microservice. And because the independent application, then scaling it, okay, or restricting it, maybe I can say search flight, I want to give a limited RAM and CPU. So any kind of control on that individual functionality is very, very simple. That was the challenge we were facing in the monolithic, but here it won't be. It is very, very, very much possible. So it means if you talk about MechMyTrip is one big application. Okay, one big application, one big portal. But in this portal and with this app, okay, we have lots of smaller functionalities. Okay, and every functionality is also known as a module, but every module we use as a independent service, is called microservice. Okay, example is search flight. This example is, let's say, promo code. Other example is, let's say, book down. Okay, now what benefit you get? Initially, every functionality, every service we run in one individual computer. Let's say computer A, computer B, computer C. But wherever we find more traffic come up, that part only we can scale. Let's say search flight will increase search more. We can add one more computer for same microservices called search flight. One more computer we add, let's say computer D. The search flight is running in the 2 different computers, but other guys were running one single computer. So every individual microservice or component, also known as, or module, it is also known as, we can scale. Okay, this is one thing. Second benefit is because they are independent. So if any code change in the promo code, that was I was discussing to you. Okay, any code change in the promo code happen, or maybe you have any bug fix here. Okay, bug come up, we fix it, or code change happen, any code or any new facility or feature we add in the promo code, this code change happen. Okay, so only this functionality you have to change, or this functionality is a one service, once an app. So we have to redeploy only this part. Or because you guys know when you do deploy, mostly this service depend upon how you plan. We'll talk about better plan, but mostly, let's say this go down for some second. Or because this is an independent computer, if this computer goes down or application redeploy, it does not impact A computer. It does not impact C computer. If somebody is searching that point in time, they have no issue in searching. If somebody doing booking now at this point in time, book now is happening properly. Okay, but that point in time, promo code might not work. Maybe some guys might not using promo code. So that part will be that functionality or that module will be down that point in time. Okay, so if my team is working or my developer is working to do some changes on one of the functionality, now that functionality is known as microservices, it won't impact the overall application downtime. Other facility can be used in the same point in time. And one more benefit you have, maybe these companies keep on enhancing, come with a lot of new facilities. When you after book the flight, previously they don't have this module of book or pay later. This facility or function they add maybe some month back. So adding this functionality, okay, is not a big deal. So for this, they create one more different microservice that is equals to functionality, that is called microservice. And this microservice is dedicated for pay later. So separate team in the company started working on the pay later. After this pay later functionality created, they make this functionality an entire microservice. And how we can convert a functional into one independent service is called microservices. That was the part of the training we'll discuss in the upcoming classes when we do the practicals. Okay. So this particular functionality, they make as a one independent app. Okay, and when this app is ready, they run this app or deploy the app in the different computer. Okay, so technically what you see here, this app or this part is dedicated running in the very different computer. We can't see it because my front end or my back end, whatever front and back end we'll see in the discussion, upcoming discussion, but they are managing behind the scene. It looked like this is a one single app, one single website, but it's not. This is running in a different computer. Promo code running in a different computer. Okay, booking, and when you click on the book or button here, this button is running in the different computer or running different microservice, I can say. Every main part or main logic or main idea here is running in different computer. But it all depends upon the developer of these guys. So whoever they design this entire system, they decide. There's a possibility promo code, okay, and pay later might work in one microservice. Okay, a promo code and continue means booking options might work in one single app. So it's not hard and fast rule that every part you have to create a separate microservice. It all depend upon the developer or the designer or the whoever designed this entire system. They plan, okay, upon the requirement. If you feel, no, this is a very common thing we always want to use together, we always want to make it tightly coupled, always work together, they put in one single functionality or one single microservices. But something they feel promo code is kind of independent, book now is kind of independent, I want to fix the bug, want to redeploy this guy alone, book now alone, I want to scale my book now alone, then these two functionality, they make it independent. This is called loosely coupled, not tightly coupled, loosely coupled. Okay, so any fixed thumb rule or plan? No, it's all depend upon the development and the design of the plan. We'll talk about a lot of best practices and scenario in my upcoming classes, but it is not hard and fast rule. It would be purely the plan and the design, whoever planned this architecture for us. Okay, but okay, having two functionality run in different microservice, different computer, different deploy in the different computer, make this two functionality loosely coupled. Loosely coupled means If something happened on the promo code, it won't impact the book now. If code is being changed, the promo code and redeploy, it won't impact the book now. How is possible? Okay. So for this, we'll go more deep into this topic. Okay, because deploying the microservice is not enough. You have to do some planning in the code also. So we'll talk about it, how it's possible in upcoming discussion. But one of the motto behind the microservices, that is very important motto, every independent functionality, or I can say every functionality, we have to make it independent to each other. If something change or happen in one functionality, it should not impact other functionality or the microservices. That's called, they're not tightly coupled, they are loosely coupled. This is one of the very important feature of the microservice architecture. Okay, so whenever you create a microservice, you have to plan the microservice architecture. And we guys will talk about a lot of architecture of microservices, what kind of architecture we guys can create. Okay, over here. Okay, so this is also one more, guys, a concept over here. One more interesting thing, guys, there is about the microservices. This is very, very interesting concept. Okay, is now guys, understand one thing, every functionality is a now become a independent service or the application. Even though they are functionality, for the final user perspective, it look like just a button. Continue, promo code. Okay, it look like one single facility of the functionality in this app or big app. But internally, they're running as an individual app, individual service. But because this is a very small service, that is called microservice. Okay, so interesting thing is now what company can do, what this company can do. Okay, they can provide this functionality to the different team or different developers and say, now this is your team responsibility to manage these microservices. Okay, so one individual team can be responsible for one individual functionality and the microservices. And because these are the different apps, so this team can decide, okay, how to develop this microservice. Okay, they have their own personal deadline, maybe, for example. Or interesting thing is they can use their own personal programming language, right? This is very interesting concept. Means if you use the monolithic, you can't do so. The promo code I can create in Java and pay later I can do C++. How can possible, right? One single file, either use C++ or Java or Scala or Python. Okay, you can't do one single program, one function create in Java, other function we create in C++, one possible. But in microservices, in one big app, every function is one independent microservice. So that team who is responsible for this microservice, development or maybe management, okay, they can decide their own personal programming language. If this team feel book now is a very important button and we need some kind of facility that Java can provide to us, so they can use Java here. But in search flight, okay, we might need some kind of AI or machine learning here or recommendation engine here. Okay, so there we need some kind of machine learning code also. So maybe Python is good enough to write this code for machine learning. So search flight app can be written in Python. So in one big app, now every microservices can be written in different languages, depend upon the choice of that team who is responsible. Plus, it is also depend upon which language is best suitable for that feature. Because guys, you guys know, if you know a little bit of programming, every language in this world has their own use cases. Okay. For example, if you want to write some driver level program and speed program, we can use C++, enterprise level program or any kind of transaction based program. Okay, you can use Java, machine learning kind of code and big data kind of code. Python can be well suited. Okay, if you want to do any kind of data engineering program or analytics program, maybe R or Scala can be used, can be well suited. So every programming language is been developed for, designed for different purpose, different use cases. Now this app is one big app, and in one big app, guys, some portion sometimes we search, sometimes we do a banking transaction, sometimes we do some maybe machine learning or AI or deep learning. Okay, now because this program we convert into small microservices, now we have this flexibility come to us. So every programming language, so if, for example, every microservices, okay, we can create on individual programming language. Now again, up to the choice of the team also, what a team we allocated this one. So we can check the competency of this team, which programming language they're comfortable or competence, or mostly this microservice, whatever the things we are doing or facility we are providing, which language is best suited for this facility. So accordingly, that language will be used. It means because of the microservice, one big app can be developed in multiple programming languages, but it won't be possible monolithic. Okay, and by some this concept, guys, is known as polyglot. One single app, if developed in multiple different programming languages, so this concept is known as polyglot programming. Okay, so means like to writing code in multiple languages to capture additional functionalities. So polyglot is a very interesting concept, and this concept can possible if you architect your software development, okay, in the monolithic way. So you can utilize all the best programming language for that particular best feature and the microservice. Okay, so that's also one great facility. And again, next facility is now we have independent team. They have their own personal deadline. This team will do their own personal research, research. Okay, there's one philosophy, guys, there's one philosophy from the Unix that what we also try to do in the microservice. The philosophy is do one thing, but do it well. Okay, so the same philosophy, guys, will apply in the microservice. So do one thing means one feature, one team, but do it well. So again, is a plan of the company management. Budget also 100 more thing, but let's say if they might give this entire microservice to one different team, and this team is dedicated for this microservice, that there's one thing they have that they try to make it best. They try to make it faster, performance wise, resource wise, trying to manage the cost also. Means they're trying to run in the minimum cost, best performance, no bug, more facility, more feature, whatever thing possible, they try to do it, make it well and perfect. Okay, but it's not only on one team. It's again vary from company to company how big the application is. Okay, so maybe 2 or 3 microservices can be part of one team. So it's all depending on the plan of project management by the project managers. Okay, but this can be possible. If sometime in the future, if you feel Now, this microservice is very critical, very important. Lots of things there happening. So a dedicated team also we can plan. A dedicated DevOps pipeline also we can build. Okay, so what DevOps pipeline? Most of guys does not DevOps, so they don't know about DevOps pipelines also. So I don't want to discuss this part right now. In my upcoming class, we'll discuss about this point. But now every microservice will have their own personal DevOps pipeline. What is this? We will discuss in the future. Okay, like every microservice is independent, so they have their own pipeline for testing, for query check, and other things also. We can do. Every microservice have different monitoring tool. So Bookna we are monitoring separately. Pay later we are monitoring separately, and 100 more things we can do, because they are independent app. Whatever you do on the independent app, from development, from monitoring, right, and to improve the performance, for DevOps pipeline, okay, that will be your choice. Even though, okay, we can do something like this also. Maybe this microservice we can run in the top of AWS cloud. This microservice we might run on the top of Azure cloud. One app, but different clouds we are running. It's called multi-cloud. So my one single app is running on the multi-cloud. Okay, there's my possibility. Okay, that when we run this microservice running on the top of virtual machine. But this microservice, or maybe this microservice, we know this microservice search more, we have to scale it. More scaling and quickly scaling can be done in the Kubernetes or OpenShift very quickly, or Docker container very quickly. And containers we can very quickly scale within a second, less than a second we scale. So that part of the deployment of that microservice can be done in the container technology like Docker. And by the way, guys, okay, those who are over here does not know about the container, that is known as, let's say, Docker. Okay, so in this training we are not going to discuss about Docker, but sometime I keep on using them, or sometime we might keep on using some Docker commands. So highly suggest, guys. So I'm not saying this is a prerequisite for this training, but for you guys, what we'll do, we will provide you some videos, those who don't know about Docker and the container, some basic video. So before the upcoming classes, I'll try to complete this video also. So whenever we'll talk a little bit about the Docker related requirement or container related discussion, you will be comfortable what I will talk in the future classes. Okay. So guys, also try to cover this point. Okay. So 2 videos we will provide to you. One about the container Docker, and second thing about the Java. Java is not compulsory, but I suggest all the code mostly that we will work on as an app that you don't have to develop, but that code I will give you in the Java, and we'll do some changes to make it microservices. So if you know Java, then you become more comfortable. Understand wise, you will understand, but in terms of comfort way, if you know Java, it will help you more to understand that concept in more detail. Okay. So that's what I explained to you also. So having the microservices give you loosely coupled things. Everything can be managed in different programming languages. Everybody is independent. Everybody can be scale it. Everybody we can redeploy it. Any kind of failure happen in one component or one microservices, okay, might not impact other microservices. Why I'm saying might not, we will discuss on those points, but mostly they won't impact much. Okay, and remaining app will run smoothly, and there's no issue come in the remaining part of it. So maybe here, maybe in the McMahon trip, the promo code microservice might goes down. So this facility might not work, but other facility will work. We can book the flight and things will work. Okay. So if you talk about, guys, this big company like Amazon or Netflix, they like this, they are running thousands of microservices. So at this point in time, if you talk about Netflix, Okay. So in Netflix like this, there's lots of small microservices running in the Netflix. So I think they have more than 1,000 plus. Somewhere I have heard, right? 1,000 plus microservices running in the Netflix. Okay. So for creating the account, to search the movie, recommendation engine, new movies, top 10 movies, presenting the movies, converting into different format of the movie in HD or normal, right? Every part has the independent microservices. Okay, but every microservice can be run thousands of times of the scale. 1,000 microservices means 1,000 different facilities they have, functionality they have. I'm talking about Netflix. Okay, but let's say one functionality is searching in the Netflix. That particular microservice can be run 100 times scale because lots of guys together searching. Okay, so every microservice we are managing, as scale, and other part also security, 100 more things we'll talk about in the future classes. So Netflix also guys switched to Microsoft for monolithic architect long back. Okay, because if you don't convert your monolithic in the microservices, then this was the issue what I was talking about, your phase, and none of the company will scale their business because nowadays the entire business is based on the application, right? What Amazon or Netflix or Uber, and more client come up. Okay, so faster you to scale, but not you have to scale the entire app. Some portion of the app you have to scale. Okay, for example, if you talk about Uber, maybe the peak time, evening or morning time, more guys will search, more guys will book. So that portion of the microservice booking or searching, if the microservice can scale that part only, remaining portion to log in the app, we don't require. To see the interface, we don't require. Maybe. Okay. So if they have the microservices, then scaling would be very quickly because we have to manage the cost also, right? If 1,000 more clients come for searching or booking the ride in the Uber or Ola, okay, why to scale the entire app? Because if you scale the entire app, it takes more time, right? Take more cost also. You have to manage the cost, right? Costing also. So because they have the microservices, then depend on the requirement to requirement, time to time, requirement to requirement, we can scale that part only. Okay, because of the microservice, we can do so. Okay, and many more benefit you will face or you will see or having the microservices. Okay, what is disadvantage of the microservices? Only disadvantage of microservices, it make your entire system, entire app little bit complex. Because here a great planning is very required. Great design is very required. So what I mean by designing and complexity and the architecture and planning, that's what the plan for my next class is. Okay, but only disadvantage of the microservices is if you don't have the better plan, okay, and if you don't have the better boundaries, that's called boundary means this microservice, what is the responsibility of this microservice? What things this microservice can do? It shouldn't be like this. The something book now and pay later will do the same thing. They will conflicts. Okay, so we have to give better responsibility. Pay later will only do these things only. Book now will do only this thing only. Because they're two different microservices, but it become one single big app, right? If both two guys are doing something common, there might be some kind of conflict come up. So having the better boundary, or I can say proper responsibility planning, is very important. Otherwise, thing will conflict or might fail, might be duplicate. So a lot of issues will face. So we'll talk about those boundaries and the better planning and the best practices in upcoming discussion. Today, my plan is to give you introduction. So those who don't know microservices, at least you get the idea that today from Facebook to Amazon, whichever app you're running, it look like one single big app. Okay, behind the scene, every portion of it is a microservices. The front end is your website or front end. We connect all these pieces together. How they connect, we'll see also in the future. So it look like one single app, but internally they are different apps running in different computer. This is called different microservices. Okay. The point here is how these microservices connect to each other. Okay, because sometimes one microservice, okay, have to connect to other microservices to exchange some information. For example, okay, if you want to book the flight, you need to fetch the flights, or maybe you have to get the promo code also. So this is a different microservice running a different computer, different microservice and different computer. But these two microservices or these two different services has been first fetched by, connected by book now. Then we can book it. So mostly you'll see, guys, mostly all the microservices will connect to each other, even though they're running independently in different computers. Okay, but they have to keep on communicating, and obviously they're running in different computer, so obviously they have to connect over the network, or the maybe network or internet maybe. Okay, so how they communicate? So this discussion I would like to do in the next class. Mostly they use the REST API or the API console or API gateway to communicating to each other. That's what we'll discuss in the next class. But they have to communicate to exchange some information, the data here and there. Okay, so next class, guys, we'll go more deep into one particular microservice. Every microservice has again there's some more subcomponents inside one microservice. We'll talk about it. Some more challenges of monolithic we'll discuss, and how to solve in the microservice we'll discuss in the next class. Okay, and then how this microservice connect to each other. Okay, then we will start writing, we can start implementing some practical on it. Okay, and for practical, we will use some simple app. So we can run as a monolithic that will convert into microservices. That time you can see the difference. Okay, mostly the app we will deploy on the top of container world. Okay, especially Docker maybe. That's what we see in the upcoming classes. And then I'll tell you some requirement. Okay, because microservice is a very common thing we have to use almost every day, everywhere. So we need some framework for management of or creating the microservice, I can say. So for this, we will need framework. Okay, so you have lots of framework available, but I told you already, mostly commonly used framework in the market for Spring Boot. But nowadays we have one more framework that's become more familiar and more advantage over the Spring Boot. Is called Quarkus. So I'll show you how to use the Quarkus. We install the Quarkus setup and we'll do things on the Quarkus. Okay, but there's no prerequisites, guys. Again, for the next class, everything we will start from very basic, but I highly recommend just have some basic knowledge of the Java be with you and the Dockers, and that video we will share to you. So you don't have to learn by yourself. From our video, you guys can understand the concept. Okay. So what is microservices? Okay, this discussion is not yet complete, but this first day, I want to conclude, guys, till here. So I'm just concluding in middle of my discussion here, because the next topic again will take 1 more hour to complete. So I don't want to discuss further. In this part, we'll discuss in my next classes. So next classes we'll do the remaining discussion, and then we will move to the practical part. The more practical you see, you become more comfortable on the microservices. But one small thing I want to ask you to do, and just use as an awareness perspective, any app, wherever you go, like for example, you go to Facebook. Okay, just be aware that if you go to Facebook, it means this login page is being run by different app together. altogether. It's called different microservice. Okay. What do you see as a post here? Community, how much community you have, about the details, search you do in the Facebook. Okay. Mostly every part is been run by different microservices running different computer, different small services they have. Okay, just have this awareness in the mind. Okay, so when you see these kind of big websites and app, we don't know what is happening behind the scene. This is my duty and responsibility to explain you. Okay, but just have this thing in the mind as an awareness perspective, so that when you see any app, you will start seeing at a different angle slowly as we learn more concepts. Okay, so see you guys in the next class. Before this, any query if you have, whatever we discussed till now, you guys can ask me. Otherwise, so next Saturday and Sunday, now onward, guys, we have a class on weekends, on Saturday, Sunday, as full classes, and we'll go more deep discussion and very advanced discussion, and the practical implementation we will do from the next classes. Any query if you have, you guys can ask me, right? So, very nice getting it. Thank you very much. No, it won't be costly, Utkarsh, right? It won't be costly because mostly we will deploy the microservices on the of container like Docker. So maybe one single instance will be enough to launch multiple containers. But all depend upon how much request is coming, how much processing going on, how much data is flowing here and there. Okay. So that part, Utkarsh, we will discuss in my next classes. Okay. But microservice is actually saving the cost. It won't increasing the cost. It looks like multiple computers they are having, but it's not like this. They're saving the cost. How they're saving, maybe my upcoming discussion next class will give you the clear answer on this point. Okay. So great session, sir. Thank you very much, Deepak. Does AWS have any service for microservices? Yes, mostly, guys. For the microservices, okay, cloud is one of the great platform to deploy the microservices, and every cloud has a lot of services available for the deployment of the microservices. One of the example in AWS is EKS or ECS. Okay. So these are the platform on the AWS cloud, Rahul, can be used to deploy the microservices. This is one of the example I'm talking about. There might be more services, depend upon what component you want to deploy there. Okay, because in microservice, we again have multiple layers, data layer, business logic layer. Okay. So if you have business logic layer, then you can use Lambda. You can only deploy the data layer. You can go for DynamoDB. Q service, you can do SQL. So we'll discuss about it in my next classes. Again, this is not the AWS training, but I keep on relating. Okay, that I want to deploy the microservice in AWS cloud, which all services you can use there. So those who know AWS, they can link that concept with that. Okay. So excellent class, sir. Thank you very much for wonderful concept. Thank you, Rishi. Thank you very much. Okay. How to microservice link? That's what first I was talking about in the last. I need a next class for this. So how two or multiple microservices connect together and make a one big app. Okay. So next class I will explain this concept in detail. Okay. So how to handle tightly coupled microservice in case one server fail? So Ramesh, that is all upon a plan. If we think there's two different concepts of function. Okay. So while planning phase, don't run two different functions in one single microservices. make it two different microservices, decouple it, or it's also known as refactoring it. And that was a role of maybe developer or the designers. Okay, from monolithic convert into microservice to two independent services. It's called decoupling or refactoring. Okay, and do it. But if you don't decouple two different functionality and run as a one single microservices, so obviously, if any issue come in one single functionality, it will shut down the entire microservice. So other facility also will be shut down or won't work. Okay, so in that case, we are not following the better practice for microservices. In this case, you will fix that particular facility to start the entire tightly coupled microservice. Okay. So Ramesh, this is what you're asking, right? But about this concept, this is the very rough answer I have given to you right now. But as we progress in this program, this kind of use case will come a lot, and I give you better practices for this. What are the better practices you can follow to solve these challenges? Okay. So what is Quarkus? Viraj, in my upcoming class, we will discuss about Quarkus, and then we might also discuss about the difference in Quarkus and Spring Boot. Okay. So single page, multi-page application, Lavanya, it is about the development perspective, especially the web development. Okay. So so if you want to give entire facility from one single app, is called single app application, right? So if in Lavanya, I think you are part of Earth-Free. So in my full stack development in MERN, is there a part of your Earth-3 program? Or those who are there in system design, also we have this MERN full stack development. There we will develop a lot of single page applications and multi-page applications. I will talk more about it. Okay, but it's just a way to present the application. Okay, but behind this application, with multi-page or single page, you can run multiple microservices. So there's no restriction, I can say. Okay, restriction on this. So either your single page or multi-page application, in both the case, microservice can be connected, right? So after so long and run for our course, your vibe is different, sir. Thank you very much, Susan. So Manish, the next weekend timing will update you on Saturday, Sunday. You will get this update in your respective WhatsApp group. So we will run the microservice, Papu, in multiple different ways. Sometimes we run in the cloud, sometimes we run the Docker container, sometimes we run on the Kubernetes. As and when we require, I keep on using multiple different platforms to give you multiple different flavor of implementing the microservice in my next classes. But mostly we will use containers. Okay. So having the knowledge of container is if you have, that will be always good. So we have a discussion on security part of microservices, vocal, right? So we'll discuss in upcoming classes. There's a concept called OAuth and all the things we will discuss there. Okay. So my company project is using microservices. Getting to know about the clear term form, you will make my life easier. Thank you. Rahul, this we have started. Next class will give you get more powerful concepts in the simpler way. So it will help you more, but it's nice if you get some things today. The way you explain to the microservice is magnificent. None of the system design course tell us this before development. Thanks, hats off to you. Thank you, Utkarsh, very much. So I'm not in the IST time zone. Manish, my team will help you. Mostly this classes would be in the evening time in Saturday, Sunday, with respect to IST time zone. Okay, but otherwise, any time issues you have, just update, ask to our team, if whatever the way they can help you. So Raghavendra, we will talk about API gateway in my next class. That time I will tell you what kind of API gateway we will going to use. Okay. Yes, Rahul, after you complete this training, here we are using podcast, but same logic you can apply in Spring Boot also. Because knowing the concept, planning, design pattern, architect designs, whatever we're going to discuss there, okay, those knowledge will be enough to work on any other platform. So then quickly switching to Spring Boot won't be a big deal for you then. Okay. Does everyone use Microsoft nowadays? Mostly Mohit. Mostly. Or in the simple term, whenever you see big app like Amazon, Netflix, and there where you see lots of customer come up, a lot of facility they provide to you, it would be guaranteed that they are using microservices. Okay, but any new company startup, they might creating the app in monolithic way. But in the future, when they become big, they slowly convert to microservice, or maybe initially they start working as a microservices. So in the future, they don't have to migrate or transform to microservices. But what you're asking is, yeah, mostly all the top companies are using microservices. So why Google is still using monolithic architecture? How we can say Chaitanya they're using monolithic architecture, but they might be. Okay, if you just talk about Google search engine, they don't have any facility, right? There's one single facility, right? The search, that's all. One single facility. Okay. So having one single big app for searching, that's what we need. So if they're using monolithic, there's no good reason to use the microservice there in the Google. Okay. But if you go to other app of the Google, let's say Gmail, they're using microservices. Because having a mail is different thing, having a chat option different thing, having a Google Meet there is different thing. Okay. Compose the mail is different thing. Searching there in the top is different thing. Okay. So there in Gmail, they are using microservices. So what is scaling order, which is better in real-time project, is all depend on project to project, Bala, but mostly in most of the example, okay, horizontal scaling is always the great things to have. Okay, but if you say which is the best one, I always say if you can tell me your entire use case, then I can properly guide, because in some of the use case, vertical scaling also sometimes good. But mostly horizontal scaling is better choice in most of the use cases. Do you advise to start learning Docker? Yes, that's what Ashish, we are advising you. And for Docker, we will give you the videos from my side. Okay, so I suggest to learn the Docker from that videos. Okay. Yes, I mean, Python training is there in the earth, right? How to connect microservices together? That's what the Ashwar is planning for my next class. Again, Istio is not there in this training. A service mesh is there as a concept perspective. Okay, Istio we will launch separate batch. If you guys want to learn, you can learn in that batch, but Istio as such as a tool is not there in this training. Okay. How much knowledge Java is enough? If you just know basic concept of Java, like how to get the classes, functions, method, just basic concepts. That is more than enough, nothing more and nothing much. Okay. So, can you use Microsoft anywhere in the app development? Yes. Kart is app, right? What example I talked about, Make My Trip is app, right? Okay. So, in the app development, the way you develop the app, you have to plan it. And that in the planning part, we have to plan that different component of the app, you have to run as separate functionality, as separate microservices. That's what Karthik we will discuss more in my next classes. Okay, so point is what you're asking, yes, obviously we have to use the microservices concept in the app development. How and why we'll talk more in my next class. Okay. So that's all guys for today's class, first class. I'll try to touch very basic concepts. So to sync you guys with the microservices, we will Astonis. Thank you very much, Simriti. So in next class, we will go more deep, more basics, and with practical also. Okay. But this is a very critical topic. Don't take this class in microservices for learning purpose. If you really want to grow in the technological world, having the great knowledge of Microsoft will help you a lot in your better profile in the jobs also, right? So that's all guys. See you in the next class. Bye. Good day. Take care. Good night. Bye. See you.